Exercise 18a, tangents and normals. In the previous videos, we have discussed the concept of a tangent line, that is a straight line in the form of y equals mx plus c, that touches our regular ordinary graph of f at just one place. And usually what we find is that at that one spot that both the tangent line and the original graph touch, that spot has the same instantaneous rate of change on the graph of f as it does on the tangent line. And we can use this to find instantaneous rates of change. So what is a normal? A normal is much as similar to the tangent line, except it is perpendicular to the tangent line. So we can see here we've got this formula here is for our tangent lines, and then for our perpendicular lines, or for the normals, they are found like this. So we have to do a number of different steps to find both the normal or the tangent and the normal. First things first, if we have no idea, we always find our derivative of the graph, of the original graph. And then we'll substitute the x ordinate to get the derivative, to get m. So we find the derivative at that particular point where the tangent line touches. And then either we form y equals mx plus c to get the tangent, or we do negative 1 over m x plus c to get the normal. So just from a very quick visual point of view, so what this looks like. So here we go, we've got some axes here. Here is my graph. And let's say this is my tangent line here, so that would be a tangent line. And it shares a gradient at that point. The normal would stick out like this. It would be at 90 degrees and it would be perpendicular. So that would be a normal. So we're going to do a couple of examples. Spoiler alert, the first one is quite in depth. It covers literally everything you need to do with both normals and tangents. So stick with it and we'll see what this is all about. Example 1. Find the equation of the tangent to y equals x squared at the point 1, 1, and the equation of the tangent to y equals 1/6 x cubed at the point 2 4/3. I'm just going to stop there just so that's already a lot of information. So if you're like, that's A, find the equation of the tangent to y equals x squared at the point 1, 1. So we're going to find that. And then B, find the equation of the tangent to y equals 1/6 at the point 2 4/3. Then C, we have to show that these tangents are parallel. And then D, find the perpendicular distance between them. Now, I'm going to tell you here with the perpendicular distance, there should actually be like a D part 1 where we'll need to find the normal line. And then part 2, we'll need to do the distance formula. Sometimes I find it's useful just to get a visual of what it is that we're actually looking for. So here is that visual. So first things first, we had the graph of y equals x squared. So there it is there. And then there is a tangent line at the point 1, 1. There's the tangent line. So you can see it's just touching at that graph at 1, 1. Then the next thing we have is we have this graph of y equals 1/6 x cubed. So there's that blue line there. And it has a tangent at the point 2 4/3. So there we go. So 2 4/3, or 1.33333 recurring. We can already see visually that these two tangent lines are parallel, but we'll have to obviously find the equations to show that. And the last step is we need to find the perpendicular distance between them. So that little tiny line in there. So we'll obviously need to know the equation. We need to know where that hits the other line. So it's a little bit involved. So I'm going to start with A, or what I've declared as A. So we're going to find the equation of the tangent at the point y equals x squared. So we're going to find a derivative, and then we're going to substitute with a point there, and then we are going to go and solve for y equals mx plus c. There's the derivative. We have substituted x equals 1 because the tangent line hits at 1, 1, and we obviously use the x ordinate in there. And now we have to develop the equation of the line. When we develop the equation of the line, we substitute both coordinates in to solve for c in y equals mx plus c. And here our m is equal to 2. And our first tangent line is y equals 2x minus 1. We're going to do the same thing for the tangent line for the second part. So we found the derivative of the second one of the 1, 6x cubed. So now I just need to substitute the x value in the coordinate at which that tangent hits, which in this case is 2 and 4/3. So we'll be substituting the 2 into this equation. So we have a gradient of 2, and we can already see that these two lines are parallel because they have the same gradient. Let's now develop the line using the y equals mx plus c formula and substituting both ordinates into that formula. And so the equation of our second tangent line is y equals 2x minus 8/3. We can see quite clearly that these two lines are parallel because the gradients, which for a straight line is the number in front of the x, are the same. The next step is now to find the perpendicular distance between them, but we need to do two parts to this. One, we need to find the perpendicular line, or the normal, that hits between the two lines, that intersects between the two lines, and then we need to go and use the distance formula to work out the distance between them. I would suggest we to start with the top equation, y equals 2x minus 1, mainly because it's got coordinates that are simple to substitute in. In this case, it has the coordinates of 1 and 1. You can do the same thing with the other graph. However, I think honestly this will be easier. So because it's perpendicular, it has a negative inverse gradient to the tangent. So the gradient of the normal line is going to be -1/2. We're going to build this normal line from the first tangent because it has simpler coordinates, in this case 1, 1. And that way it'll be easier to find the c accordingly. So we found the normal line, and what I thought it might be useful is to visualize where we're up to in this problem. The red line was the first tangent that we found. The green line is the second tangent that we found. The pink line here is the perpendicular normal line that we found, starting from 1, 1. And now we need to find the distance. However, we don't know where this intersects. Unfortunately, it doesn't intersect at 2 and 4/3. We saw that in the visual a little bit earlier. So now we need to find where this green line intersects with this pink line. So that means we're going to have to make the two equations equal to each other so we can get some coordinates. Once we have those coordinates, we can then go and use the distance formula. So we found the x value of 5/3, and now we need to find the y coordinate. We could substitute the x value of 5/3 into either the normal or the second tangent equation. We would get the same answer. So the tangent line, the second tangent line, and the perpendicular normal line intersect at 5/3 and 2/3, or 5/3, 2/3. So now we just need to find the distance, which we can now use the distance formula. The distance formula looks like this. If you'd forgotten about this from chapter 2, which is the square root of y minus y1 all squared plus x2 minus x1 all squared, remember that it's just an extension of Pythagoras' theorem. Essentially what we are doing is we're making a lovely little right angled triangle and we're finding the hypotenuse. So let's solve. So the distance, the perpendicular distance between the two lines is the square root of 5 over 3. Let's just take one final look at all the working out we had to do for this question. Example 2, the curve with the equation y equals x minus 2 brackets, x minus 3 brackets, x minus 4 brackets, cuts the x-axis at the points p equals 2 naught, q equals 3 naught, and r equals 4 naught. In other words, those are just x-intercepts. So cuts the x-axis just means x-intercepts. And we could tell that already just by looking at the brackets. Prove that the tangents at P and R are parallel, and at what point does the normal to the curve at Q cut the y-axis? So this sentence here, at what point does the normal to the curve at Q cut the axis? It just wants the y-intercept of the normal. So when we got y equals mx plus c, it just wants that. And in that first one, that proved that the tangents at P and R are parallel, we just need to go and check the gradients, or the m values, which is the same as gradient. So when we do a normal and a tangent questions, well, if in doubt, we better go and find the derivatives. So for this one, I would suggest that we need to expand these brackets first, and then we can do the derivative accordingly. So we found the derivative, and now what we're going to do is substitute the x values at both P and Q, and if they come up with the same answer, that means the derivatives or the gradients of those tangent lines would be the same. So the gradient when x equals 2 at the point P 2, 0 is 2. And now we're going to check to see what the gradient would be at the coordinate marked R, which is at 4, 0. And because both of those gradients are equal to 2, we have shown that these are parallel. The last step that we need to do is to find that the equation of the normal at the point Q, and once we find the equation of the normal at point Q, then the C value in that equation will give us what the y-intercept is. The first step we need to do to find the normal to the curve at the point Q would be to find to substitute what that coordinate 3 would be into the derivative, and then do -1 over that to find the normal gradient. So the value of m, or the tangent gradient, when x is equal to 3 would be equal to -1. Therefore, the inverse, the negative inverse of that would be -1 over -1, which is equal to 1. So that just leaves us to find the equation of the normal, which what we'll do is we'll use that value, that 1, to substitute in for the -1 over m. And then what we'll do is we'll substitute the other coordinates for point Q, the 3 and the 0, to solve for C. So we found our equation of the normal line, and the C value is -3. So the question was, at what point does the normal to the curve at Q cut the y-axis? Well, that means what is the y-intercept? Therefore, the y-intercept would be 0, -3.